No videos tonight, so we can avoid that complication. But I found out, Sam just revealed to me that I was recording myself singing that whole time, so we'll want to erase that part. I didn't know the words to that last one. Okay, are we up there? We're up there. So I know we have some people joining us who were not here yesterday. Wait, I put a slide above this. This is the sort of mission. What I'm trying to do in 4 talks, again, is to equip you all to recognize and firmly reject the most influential counterfeit origins account of our day. And we talked a little bit yesterday about what that is. And in a nutshell, it's this physicalist, naturalist, materialist thing that gets conflated with science as though science demands it, and it doesn't. But science textbooks will often take this worldview that says there isn't anything other than the stuff that scientists study. There isn't anything other than the material world. And that means that we got here through strictly material processes. God did not have to exist in order for us to be here. All of this, they say, is perfectly well explained in terms of scientific theories like Big Bang theory, theory of the origin of the universe, and most notably Darwin's theory, the theory of the evolution of life. He didn't actually in his theory include the origin of life, but then you have people who have theories about the origin of life as well. So those 3 things: origin of universe, first origin of the very first primitive life, and then Darwin's theory supposedly explains how natural processes could go from that first cell to everything we see around us that's living, including us. And it's false. And not only is it false, it's not that a bunch of people who are honestly seeking the truth got some things wrong. That has happened along the way. But it's also the case that people who are actively, Romans 1, rejecting the truth have had to come up with an alternative account. And this is the account they've come up with. And I don't think it's actually the most, probably your friends who aren't believers, a lot of them don't buy this materialist, physicalist thing. A lot of them will be sort of spiritual in some way. They just don't like Christianity. So it's not that this is necessarily the most common thing that's out there other than Christianity, but it's still extremely influential because educated people all kind of gravitate to this as the way smart people think about origins. And for that reason, I want you to be well equipped to show why this is false. And so yesterday we looked at refuting materialism itself, the idea that everything is physical. We decided there's a way you can show that's not true. Namely, you can show that we aren't just physical. We do have physical bodies, but there's an aspect of us that definitely can't be physical. What's that aspect? Or there's a part of us. Our mind, soul, spirit, this immaterial aspect to us can't be explained in terms of just physical processes. It doesn't work. If you try to do that, you end up with a contradiction that undermines the whole thing, right? So today, we're going to look at Darwin's theory, which we didn't do on Monday. So today, we're going to look at the fantastic improbability of Darwin's theory. 4 accidental causes, random mutation and natural selection, to have made everything that we see around us, all the living things, would be exceedingly improbable, fantastically improbable. And then tomorrow, I'm going to look at the most used way to try to get around what I'm going to say today, and we're going to see that it doesn't actually work. And then Thursday, I want to do something that's more, is less about argumentation and more about wow factor. I just want us to be wowed. I want us to end on something that's very worshipful. I think all of this can be worshipful. There's different ways to worship. You can worship doing math, right? But I think for most of us, what we'll do on Thursday is just stepping back and looking at what is so stunning about what God has made, with the mindset that anytime a creator creates something, he or she leaves something of himself or herself in the thing created, right? So anytime you look at a piece of art of any kind, the person who poured into it left something of himself or herself in it. And that's got to be true of what God has poured himself into as well. So that's what we'll focus on Thursday. Okay, So today, the fantastic improbability of Darwin's story. Here's a great quote from Vincent van Gogh. Great things are not done by impulse, but by a series of small things brought together. And great things are not accidental, but must certainly be willed. Okay, so he's saying spectacular things always have someone behind them. And like I don't know what he was referring to specifically, but this applies beautifully to the spectacular things we see in this room and out there, the living things, right? They don't happen by accident, only by a willing them and bringing them about. Okay, so we're going to look today at causes, potential causes, or the categories of causes for physical things. And physical things are too many for us to name, right? There's millions and billions of physical things around us. Their causes all fall into these three categories. And they could be multiple of these categories, but the causes of physical things are always going to be either chance or physics or what I'm calling craft. And I use the word craft intentionally, not design, because I want to affirm that the physical universe is a design thing. So God made physics. We're not saying that God didn't make physics. But by craft, I mean someone reaching into the physical substance of the universe and doing something specially crafted to get a special outcome. So this is what we do when we do art, right? When we're making something, or construction. When we're making something, we have something in mind that we want to make. We go grab tools or whatever, we cut down a tree, we dry the wood, we carve the wood. We're taking physical stuff and crafting it into something according to what we have conceived in our mind. That's what I mean by craft. So we can affirm that the physical universe is God's creation, but when God crafts something, he's reaching into his creation kind of the way we do when we grab stuff and make something out of it, and he's making something very purposeful out of it, using the created material as the raw substrate with which to work. Do you get the difference? That's what I mean by craft. Okay, so let's look at these three categories. There are certain things. Is there anything that's well explained by chance? Is there anything that we could say, oh, how do you account for this? And we might say, well, it's just chance. It just happened. Sure, there are lots of things like that. So alphabet soup is an illustration that I like to use. It's letters, pasta letters in soup. You pour a bowl of it. When you were a kid, probably a while since you had alphabet soup, I don't know. You played around with it, right? And you either made words out of the letters or you try to find words in the letters. So here's just a photograph of alphabet soup. If you look at this long enough, you can find hints of words in there. They're short words, and you usually have to do a little bit of work to find them. So 3-letter words, fly and see and may, but it's not spooky, right? It's not like someone put those there. It looks like a coincidence because you're having to do some work to find them. A 4-letter word, rose there, but again, you have to do the work to kind of follow the letters around because it's what you would expect if something random just happens to have some things by coincidence. And that's well explained by chance. Now, there are things that are not at all well explained by chance. We talked about galaxies Monday, but spiral galaxies, so these are two different galaxies. They have a sort of beautiful geometric shape to them, this spiral form to them. And would chance be a good explanation? When people first saw these in telescopes and someone said, are those stars? Yes, they're stars by the billions. Why are they arranged in this spiral shape? And someone could say, well, it's just random. I mean, stars are out there, they have to be in some shape. It's just random. Would that be a good explanation for why you see thousands and thousands of things that are in this shape? No, because there's regularity to it. So you'd say, that's a ridiculous explanation. It can't be chance. So what could it be? We said we have the 3 buckets: chance, physics, and craft. Ethan? Yeah, we could say, and maybe we could say, I suspect there's a physical reason for this. And we might say, well, I don't know exactly what it is, but there's probably a physical reason. It turns out there is a physical reason for this, that gravitation, the laws of gravity, which are physics, cause things to be attracted to a massive center. So at the very center of every galaxy, It's thought that there's a black hole, actually, at the center of a galaxy. But there's a massive center of each galaxy, and these things are orbiting, rotating around that massive center, and that's why you get this spiral shape to them. Here's another one close to home. Okay, so if someone were to say, wow, all these snowflakes have six-fold symmetry to them, they have 6 points on them, could that be chance? Well, ice has to freeze some way, so maybe it freezes with 6-fold rotational symmetry. No, again, it can't be chance. Again, this would be ascribed to physics, and you may not know, anybody know why water freezes this way? Where's their geometry in, where's the geometry that does this in physics? Did I hear it? Was it molecule of water? What about the molecule of water? Who's speaking to me? I'm hearing God. God is answering. Was it Ernesto who's talking? Yeah. Well, that's why water attracts to water, but where does the angle come from that gives you a 6-fold? There's an angle somewhere. Where's an angle? What? Yes? Yes, it's the molecule itself. So oxygen, it's the Mickey Mouse molecule, right? Oxygen, and then it's not hydrogen, oxygen, hydrogen in a line. The two hydrogens form an angle, and then they become attracted to the oxygen, so you get this built-in angularity to the water molecule that when it crystallizes under certain conditions, you get this sort of symmetry to it. So physics explains this. Now, if we go back to so we said chance, physics, and craft. Chance is a good explanation for certain things. Physics is a good explanation for certain things. I'm claiming some things refuse to be explained by chance and physics, and they must be explained by craft. So if we poured our bowl of, if someone had the pot of alphabet soup on the stove and you lift the lid on the alphabet soup in it and you saw this, you would know for sure that this didn't just happen by boiling up a pot of alphabet soup, that somebody with too much time spent some time arranging letters to say pasta on the top of the alphabet soup. This requires craft as an explanation. Now, could someone say, I agree with you, that couldn't be chance, because it's so unlikely that chance would give a word spelled out in letters, but I think it's physics. I think physics would do this. Does that sound plausible? No. Any sort of intuitive reason why that doesn't seem to work?
Physics can't read.
Physics doesn't have language built into it. Physics doesn't know how to spell, right? So sure, is there physics going on here? Like the letters are floating for a physical reason, and you get surface tension between them, so maybe they bump into each other and stick, and that's physics. But knowing how to spell a word is not physics. That's something that comes from something else. So this has to be explained as a product of craft. And this is very familiar to us because all the things of technology, all the things that humans labor over are crafted things. That's why we labor over them. We're putting stuff together so that it works to do something special, and chance and physics won't do that. Someone who knows what he or she is doing, often lots of people who know what they're doing, go through design iterations, make prototypes, try to get something that works, and then they end up with a product that does work, and they get rich because you buy it. So if that's true of the things that we make, things that are this complex, if they have to be crafted, we're asking, how could it not be true of these things? So these are the things that we're surrounded by on planet Earth, and I suspect we're the only planet that has these things. And these are far more remarkable than a smartphone, okay, or anything else that humans have made. And if it's right for us to infer that a smartphone had to have been crafted, it couldn't have come about through chance and physics, surely it's right to make the same inference when we look at these things, right? Because these are way beyond what humans have made. Everyone, even the atheists, even the ones who use Darwin's theory as an explanation, agree that these things require a special explanation. So this is a quote of Richard Dawkins, again from The Blind Watchmaker. He's an atheist, who believes Darwin's theory is the explanation, but he says at the beginning of his book, the complexity of living organisms is matched by the elegant efficiency of their apparent design. If anyone doesn't agree that this amount of complex design cries out for an explanation, I give up. And then he says, no, on second thought, I don't give up, and that's why I'm writing this book. But what he's saying is, everyone who looks at these things has to see something so remarkable that they know this needs a careful explanation. Okay? So he says it cries out for an explanation. These are our only three categories of explanation, causes for physical things. If we say chance is the explanation of life, we're saying, or of anything else, we're saying it just happened. So there is no explanation. So that's like the random three-letter words in the alphabet soup. We're saying, well, there isn't really a need for an explanation here. It just happened by chance. If we say physics is the explanation, well, that works only if the thing to be explained fits the nature of physics. So the spiral galaxy, the snowflake, and lots of other things fit physics. But if we say craft is the explanation, then we're saying someone did it. Okay? Someone is responsible for this. Someone intelligent is responsible for this. And that's the only explanation for things that display cleverness. Things look like they required cleverness to be put together. When I was writing in 2016, I wrote this book called Undeniable. I came across this quote while I was writing. UC Berkeley psychology professor Alison Gopnik, she wrote this in an article in the Wall Street Journal. She said, by elementary school age, children start to invoke an ultimate godlike designer to explain the complexity of the world around them, even children brought up as atheists. And I thought, that's very interesting. You don't need to be taught, apparently, if you're a human, you don't need to be taught that God made butterflies and trees and cats and dogs and humans. It's innate that young humans, when they start to explore the world and see these things, they have this innate intuition that these things must have been made by a godlike designer. And that's even if their parents don't agree with that, and their parents are going to try to convince them otherwise. So there must be something that's recognizable to a child who's too young to do a complex calculation or too young to have been in a scientific laboratory. There must be something that allows children to see this. And I think, I'm going to show you what I think it is, but first I want to take you in your imagination to a park in Taiwan that is famous for natural marble formations. And it looks like this. There's a part of the park. There are these trails and bridges and walkways for you to explore all of these beautifully wind and water carved surfaces of natural marble. And so imagine that we're on a Joshua Wilderness Institute trip to Taiwan, and we go to this park, and you're wandering around through some of these valleys, admiring the beautiful shapes, and you come around a corner, and you see this. And that's marble, okay? And all the stuff in that scene is marble. But you know, and I think if a 4-year-old were with you, the 4-year-old would know, oh, that didn't happen the same way that didn't happen the same way these other surfaces happened. Someone took a piece of marble and made that, right? Someone had to fashion it. What is so funny? So we're wandering through this park. We see this. And does the child who sees this and recognizes this have to know anything technical about the structure of marble or the way you shape marble or the way the marble gets weathered? Do they need any of that? No. They just see something that they know required brilliance to make, something that requires know-how to make, something that looks intentional, and that's not what the walls look like. They don't look intentional. They might be beautiful, but this is beautiful in a different way. It's intentionally beautiful. Okay, so what exactly are we spotting, or what would the child be spotting when they spot cleverness or craftedness? We could put the question this way. What would make something both obviously crafted and provably crafted? Because what we'd like to do is say, the 4-year-olds are right when they see that the butterfly and they say that was made by a godlike designer. But we'd also like to say that you can go and do technical work and show that the 4-year-old was right, right? So what would it be that is makes something both obviously crafted and provably crafted? And I think the answer is high-level function, something that does something that ordinary physical stuff doesn't do. So a snowflake doesn't have high-level function. A galaxy doesn't have high-level function. A sand dune doesn't have high-level function. But this does have high-level function, and so does a cricket and a grasshopper and a tree, okay, and a human. They all have high-level functions, meaning they do things that are way beyond what the raw physical materials of the universe or planet Earth do. Oceans do beautiful things, volcanoes do beautiful things and magnificent things, and there's power there, but there isn't a high-level function. A volcano erupts or doesn't, and that's all it does. Whereas a smartphone does much, much higher stuff on a different level, and so does life. So the things that show high-level function are, I call them inventions. And those can be things that are very complex that you get a patent for, that have diagrams like this with thousands of parts. But they could be something much more common and much more familiar, something like a text message, right? The CAF is the cafeteria at Biola, by the way. So any short text message is we're arranging things to achieve a high-level function. In this case, it says meet at the CAF in 15 minutes, question mark. So you're proposing to meet someone in a certain place at a certain time. That's a high-level function. That requires someone who knows language and wants to do something, who constructs something, in this case a text message, in order to accomplish some high-level result. Snowflakes don't know how to do this. People know how to do this. It's a language thing. So all of these things have a property that's called functional coherence. They have this hierarchical structure to them. I don't know what all the leaves on the bottom mean, but they keep popping up. What does it mean? It means see. Okay, we'll just ignore it. I don't think anything bad is going to happen. So it's this hierarchical arrangement where at the top level, these circles just represent sort of a whole thing at the top that consists of parts within parts. So we can work our way down a hierarchy where we have the top level thing that performs a high level function. And in order for it to do that, it needs a lot of things in it that perform sub-functions and things within them that allow them to perform those sub-functions, all the way down to elementary constituents, simple things. And this thing on the top, it could be a paragraph or an essay, like you guys write. Do you write essay? You write something like at the end of a section, okay? Like an essay? Okay. So your essay is your top level thing. How long are your essays? 3 pages. 2 pages. So paragraphs or sections might be the next level down. You might have 2 paragraphs in a section. You have sentences in a paragraph. You have words in a sentence. You have letters in a word. So it's a bigger hierarchy than this. And there's something you're trying to do with that top level essay, and it can only be done by mastering all the arranging of the smaller things to get that essay, right? Ultimately down at the level of putting together letters to spell words and putting together words to make sense, to make sentences. And all of those things, the arrows pointing up here are pointing up because all of the things you've done, down to the very letters, are done for the purpose of the top level thing, right? Why did you spell that word? Because you're writing an essay, and this is the right word for this sentence to make sense in the essay. This is a very general picture of what the structure of an invention looks like. It has layers of things that have been arranged just so in order for the top level goal to be met, in order for that top level function to be performed. So here's a definition of functional coherence. It's the hierarchical arrangement of parts needed for anything to produce a high level function, each part contributing in a coordinated way to the whole. Okay? All the things that we're talking about that perform high level functions have this property to them. So if we do our we won't actually pair, but we'll do a think, pair, share. My question is, does this exhibit functional coherence? Let me go back to the definition. The hierarchical arrangement of parts needed for anything to produce a high-level function, each part contributing in a coordinated way to the whole. Does that apply to this? I heard a no or an Did I, Emily? No? I thought I heard a Okay, does this exhibit functional coherence? Yes, I'm seeing nods, yes, yes, yes. So I think it does, but I think we also need to slightly modify the definition, because what we're saying is when we came around the corner in the park in Taiwan and saw this, everyone goes, whoa, someone did that. And I think it is functional coherence that you see, or high-level function that you see, but someone could say, well, that only has one part, right? It's just a chunk of marble. It only has one part. But that's not really capturing, in what sense does this have lots and lots of things going on, even though it's not lots of parts the way automobile transmission has lots of parts. It's one piece of rock, but there's lots of aspects to it, right? And it's the shaping of the surface that's the aspects to it that allow us to see a human figure in motion. This is David, by the way. It's Bernini's David. So yes, that exhibits functional coherence, but let's modify the definition and say it's the hierarchical arrangement of parts or aspects or circumstances needed for anything to produce a high-level function, each part contributing in a coordinated way to the whole. So my next question with respect to this is, what's the high-level function? God is speaking again. It's giving us this impression of a human figure, right? So the and most chunks of rock don't do that, right? But when a chunk of rock has been masterfully shaped in this way, it gives us an immediate impression that we're looking at something other than a chunk of rock, right? And it only does that because all of these aspects of it have come together in such a beautiful way, such a masterful way. So yes, this exhibits functional coherence, high-level function, and the function is an artistic function of conveying not just that we recognize a human form, because you could have a very crude statue that we could have done, and someone say, oh, that's supposed to be a person. But this is like awesome, right? So it's not just that it is recognizable as a person, it's that it has properties like motion and fluidity to it that are really contradicting the rock material that it's made from, because rock shouldn't look like this, but it does. Have you ever seen sculptures like of a woman with a veil or something? And they're made in marble, so it's a rock, and there's hardly two more different things than, say, lace and marble. They're as different as can be, but a master can turn a hunk of marble into something that looks like it's lace flowing in the breeze, right? Only someone who really knows what they're doing can do that. Bernini, in this case, did know what he was doing. Okay, so yes, that's functional coherence. So our answer here, what would make something both obviously crafted and provably crafted? It's high-level function, and that always displays purpose and cleverness, okay? Purpose because it's all arranged to do that top-level thing, and cleverness because it requires some know-how to do the arranging. If you don't know how to write or you don't know English, you're not going to be able to write that two-page essay that you guys have to write. Or if you have to write an essay in some other language and you don't know it, you can't do it because you don't have the know-how. So only by mastering the principles that are needed to produce the high-level thing can you do this arranging, and that's clever. It takes understanding, it takes an objective that you're trying to achieve, and it takes cleverness, know-how. So let's go back to this. This is not very clever. This is a 5-letter word spelled in alphabet soup. Is there a way, now that we've kind of organized this way of analyzing this and saying this displays functional coherence on a very modest level, it's a single word, is there a way that we could actually show that this is unlikely to happen by chance? Or, let me put it a different way. if we were to pour out bowls of alphabet soup, how many would we have to pour out before by chance you would get something like this? Is there a way? Yes, lots. Is there a way to get a number?
I mean, if you do them.
Oh, so by experiment, just nope. That would be one way. I think that would be very hard. Is there a way we could calculate a number without wasting tons and tons of alphabet soup?
Could you like count all of the letters and everything and then put it into something to like calculate the formula of the probability of those specific 5 letters?
Let's do that. So here's one way to do it. Here's one way to do it. Let's put a grid on this where the grid squares are about the size of one of the pasta letters, and I've got 3 times 7 is 21, 23 squares here, and there's something unusual about all of these squares in this picture, right? The 5 in the middle are unusual because they have letters that are arranged correctly to spell something, and I said it was 23, so the 18 around it are special because they've been cleared, relatively speaking, of letters. So it gives you a cleared space and then a 5-letter word. And we could say, well, how unusual is the situation that we have here in each of these squares? We have 18 squares that are cleared relatively of letters, and we have 5 that have letters arranged. You can do a calculation like this. The 18 squares, say, are 1 in 10 unusual, and all we're saying is if we continue this grid over the whole pot of soup, you'd probably have to look at least 10 squares before by chance one of them would happen to not have pasta letters in it, something like that. And we're saying that the ones that have the spelled word are even more unusual because they have not just a letter in them, but the letter is oriented correctly and it's the right letter to spell a word, right? So those are more like 1 in 100 unusual. Okay, so if this is roughly true, and these numbers don't have to be super accurate. Oh, I just hit my microphone. If this is roughly true, if we take these to be roughly true estimates, we can now do a calculation that tells us how unlikely is that whole pattern. And the calculation looks like this. The whole pattern is 1 in 10 to the 18th. So that's the 18 cleared squares are 1 in 10 unusual, times 100 to the 5th power. And those are the 5 squares in the middle that are each 1 in 100 unusual. And this is how you multiply out improbabilities. Each one of these things is mildly improbable. But to get the improbability of the whole thing, you multiply out those improbabilities, and it looks like this. And if you've done the mental math, the answer is 1 in 10 octillion. Okay? So this simple thing in a bowl of alphabet soup, we've just calculated, is 1 in 10 octillion unusual, which means if we did it experimentally, if we did it Emily's way, we'd be here a long time. 10 octillion bowls later, you get a word that pops out in your soup. This is beyond all the oceans of planet Earth being alphabet soup. It can't be done. So what's the point of this? This is effectively impossible, and it's not a very complicated thing. So if things that are this simple are impossible, numerically impossible, then the things that are much, much more complex are going to be just staggeringly impossible to happen by chance. And remember, we only have these categories: chance, physics, and craft. So if it doesn't come out of physics and it doesn't come out of chance, then someone had to have done it. If you take any invention like a digital camera, you don't have to take it apart to know that there must be parts within parts. There must be a hierarchy. You can take it apart. If you do, this camera looks like this. If you take it apart, you'll never get back together. But you don't have to know. What's that?
I just have never seen it.
I don't know what each of these parts is doing, but we know that they're there for a purpose, right? Or they wouldn't be in the camera, right? Each one of these is designed to perform some sub-function that's important for the function of that camera. But the 4-year-old wouldn't really need to do, you hope your 4-year-old won't do this to your camera, but all you need to do is see, oh, this does something. When you hold it up, it has an image on the back of it, of whatever you're pointing at. It takes pictures. So it does something that's extraordinary. And that would tell you that this has to be an example of functional coherence. If that's true of things like a digital camera, if this staggering organization of complexity, hierarchy of complexity is true of things that humans make, how much more true is it of the things that God has made and of us as the most exquisite things that God has made? So I'm a biologist. I know you aren't all, but some of you will be or on your way to being. We're going to go through some of the layers of complexity in a human body. And we've already said yesterday, is a human just a body? No, but a human is a body with more to it. So it's more complex than this. But if we just look at the physical complexity of the body, this is a rough diagram of the organ level complexity of the human body, missing the largest organ, which is the skin. And I just think that would have looked really weird to put the skin on this diagram. So this shows roughly how many organs there are in the human body. Every one of these is performing one of those sub-functions in order for the human body to do what it needs to do. And you could look at any one of these and see complexity within it. So here's an eye, and we're looking here at the different tissues, the retina, the cornea, the sclera, the vasculature that enable the eye organ to do what the eye needs to do, for a human to do what the human needs to do. And we could look at any one of these tissues, the retina, for example, and see that it has complexity within it. This is the rod and cone structure, close-knit cellular structure of the retina that allows the retina to receive photons that have been focused through the lens onto the retina in order for a signal to be given that goes through the optic nerve. We talked about this when I threw my phone to, who did I throw my phone to? It was Zeke, yeah. We talked about this yesterday. About you seeing the phone in the air, and we played some music, and all of this is happening, and the signal goes through the optic nerve, is processed by the optic center of the brain, but at some point it gets handed off to a non-physical part, the conscious, mental, mind, soul, spirit that allows Zeke, in that case, to know he has to catch something. It's coming at him. If we look at any one of these cells, we see complexity within the cell. Here's a diagram of a single animal cell that shows you how much staggering complexity there is on the inside of a cell. And we won't talk about all, they're called organelles on the inside, or some of the things are called organelles. You'll know what some of these are, right? You know what this is. Right there. Did you say it's the powerhouse of the cell? I have a colleague who hates it when people say that. So we like to say it. Mitochondria, powerhouse of the cell. Any one of these organelles has staggering complexity within it. So we've gone all the way down to the cellular level. You can go to the subcellular level, all the way down to the molecular level. So this is a single enzyme inside every cell in your body. And this, anybody know what this is? It has RNA in it. It has RNA in it and protein in it. It has RNA and protein in it. It's an enzyme. It has RNA in it and protein in it. It's an enzyme. It is called it is what reads mRNA and makes proteins. Ribosome. It's the ribosome. So this is like the protein manufacturing factory that reads along an RNA message and decodes it and makes protein chains, including the protein chains that are in the ribosome. Absolutely staggering complexity at the molecular level that performs a high-level function. What was that? Ribosome, the ribosome. So, and the structure of this was determined relatively recently, like 15 years ago. So here is where when I was praying to the Lord, like, what should I do that could glorify you in the sciences. And he led me down this path of, well, looking at these things, how hard is it for a chain of amino acids to fold into one of these forms? There's thousands of them, tens of thousands, hundreds of thousands of them, in order for them to work and do something inside the cell. And that's what led to the project that I talked about yesterday. Or was it this morning that we talked about? It was this morning. The penicillin resistance project. So let me just show you. Here's the molecule that I looked at. This is another enzyme called beta-lactamase, and that's penicillin there in the green. But I want to tell you, this might be review, but do you know how DNA is A's, G's, and T's, right? And RNA became famous like with RNA viruses, right? Okay, and RNA is what a cell does when it reads a gene and it produces another message that's got pretty much A's, C's. Are you doing the RNA dance back there, Kylie? I think you were doing that. So RNA is not A, C, G, and T, but what is it, Kylie? A, C, G, and U. And the ribosome is reading along this RNA message and figuring out what amino acid needs to be added to a growing amino acid chain, and it's using the genetic code to do that. And the genetic code, we represent it in textbooks like this. It reads 3 at a time. So you see UCAG on the top, UCAG on the side, and UCAG going down on the right side too. So whatever that triplet is, this table tells you, oh, the ribosome is going to put a proline in here if it's CCC. Or if it's AUC, what's it going to do? First letter is A, second letter is U, second letter is C. It's going to be isoleucine. You probably can't see it from there, right? This is the genetic code. So what I did is I took the gene that makes this, which is beta-lactamase. This is the enzyme that breaks up penicillin. This is a bad enzyme in bacteria because when you get an infection and the doctor prescribes a penicillin antibiotic like amoxicillin or ampicillin and it doesn't work, it's because the bacteria are making this. And so I took advantage of that to mess this up, change the amino acids in this in groups, shuffle it around, and then put those messed up versions in bacteria by the millions and put those bacteria on Petri dishes with a little bit of penicillin in order to see whether the messed up thing worked or didn't work. And that's how I got a number on how hard is it to make these things work. So the question I was asking is, in general, if you had to put together protein chains to fold and do something, how hard is that? Is it easy or is it hard? And it turns out to be hard. It's very easy to mess these up. It's very hard to get it right. The result was published in this paper in 2004. We talked about it. 1 in 10 to the 77th power, 1 in a trillion, 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 which is a very small probability. If you think of this in terms of hitting a target, and if we go back to the Darwinian story and say, well, these targets had to have been hit by chance. God's not there. Life was cobbled together by accident. That means some chance process has to hit these targets by accident that are the right sequence for a protein chain to fold and do something. Well, how hard would that be? 1 in 10 to the 77th power hard, 1 in a trillion, 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 which means it's not going to happen. To give you an idea of how likely that is in terms of the picture of hitting blindfolded a target. Let's imagine you're blindfolded. There's a wall out there with a target. You're twisted around so you don't know where the target is. You throw your dart, and if you hit it, it's entirely by luck, right? Well, to hit a target of this size by luck would be like having a target the size of a hydrogen atom on a wall the size of the sphere enclosing the visible universe. Okay? That's not going to happen by chance. That's not going to happen by chance. And if it did, it would give you one of these working proteins, whereas for an organism, you need thousands of these to work. So it's absolutely impossible by chance. So that brings us to this term, fantastically improbable. Yes, Peyton.
Did the bacteria actually survive?
Say that again.
Did the bacteria survive?
They did, but only because I only shuffled a group of 10 at a time. So if I had shuffled the whole thing, they never would have survived. It would have been 1 in 10 to the 77th power. But since I took a little group and shuffled this group, I got like 1 in 100,000, 1 in 500,000 here, 1 in 200,000 here. And then I did the math and said, well, what if you shuffled all of these? And then it comes out to 1 in 10 to the 77th. And actually, one of the ones that I didn't get any coming through. So I did like several sections of this and counted up a number for each. One of them, the number was 0. So I didn't get anything coming through. But I said, well, it could have been as high as 1 in 500,000. And then you multiply those out. That's how I got the number 1 in 10 to the 77th. Fantastically improbable means so improbable as to be exceedingly unlikely to happen by chance at any time or place in the universe. So the stuff of fantasy. You don't like that, Haley? She's looking at me. There's a great look when we were doing the worship, and Kara was at the piano. She was sitting up there at the piano, and she was looking back like, what's going on back there? Anyway. I shouldn't have said that. It's like the tempo or something was not to her liking. Fantastic improbable. So improbable as to be exceedingly unlikely to happen by chance at any time or place in the universe. When you get to numbers like 1 in 10 to the 77th power, you're in this realm where the universe isn't big enough or old enough for something like this to happen by chance. Okay? So I gave us 3 big ideas on yesterday. Here are the 3 for today. Big idea 1, and then we got like guys' night, and we got guys' night. I don't know if there's a girls' night. There's no night for the girls. Every other week? Huh? All right. Okay, well, we'll let you figure it out. Big idea for anything but crafting to make something with deep functional coherence would be fantastically improbable, okay? And we came up with 1 in 10 octillion for a 5-letter word in alphabet soup. We came up with 1 in 10 to the 77th power for a single small protein molecule. If you want to do something like a cell or an organism, it's going to be way, way worse than that. Second big idea, to hit a fantastically improbable target is, in effect, physically impossible. There just isn't enough time or space in the universe for these things to happen by accident. And our last big idea is conclusion. Life is indeed a work of divine genius. So when that 4-year-old sees the dragonfly in the backyard and says, it was made by a godlike designer, Mom and Dad, you're wrong, you atheists. The 4-year-old actually has it right. There's a simple intuition by which the 4-year-old arrives at that, but we can do something much more complex than that, and when we're all done, we say, yeah, the 4-year-old had it right. There was something obvious about that. That's it. Thank you for your attention. Oh, that's it, yeah. Because we've got guys' night at 8, but I can take questions.
Would the second law of thermodynamics also kind of disprove any chances of straight up things forming and all?
So the second law, that's a great question. The second law of thermodynamics, can you state it?
I don't know the exact, but I know it's like something that will
Something
entropy.
has something to do with entropy. Anyone state the second law of thermodynamics for us? Yeah.
Anything that is organized tends of time to become disorganized.
Anything organized tends over time, just if left to itself, to become less organized, like your dorm room, right? So a way to state the second law of thermodynamics, it does indeed have to do with entropy. Entropy is a measure of disorder, and the second law of thermodynamics says that in an isolated system will tend to become, the entropy will increase in an isolated system, which means that isolated systems, if nothing is intervening and doing something, they will go from higher order to lesser order. So, Peyton, the question was, can you go from that to say you can't get life? A lot of people, is that the question?
Yeah.
That's a common argument. It's actually, that is the argument that when I was a student in a chemistry class at UC Berkeley, the professor bashed and said, this is a dumb argument and here's why. And then he went on to say, he was like railing against theism and Christianity. And I was sitting there as a young Christian. Is that a question?
Yeah.
Well, let me finish up here. It turns out what he was saying was it applies to an isolated system, and Earth isn't an isolated system because the sun is providing energy to the Earth. So he said, you can't make that inference from the second law because Earth is not an isolated system. But more careful work since then has said it's not enough. You can't get remarkable things happening just by shining light on something. Just by giving energy, you can't get the sort of things happening on Earth that have happened on Earth. So much more careful analysis since then has shown that it's not enough that you have an energy source. You have to actually have an energy source that drives something that is built to arrange things in a careful way. So it's not a simple argument, but you can go from the second law to that. Jacob.
You were talking about how it was like
Van Dam.
how it was very impossible to get a protein chain.
To get a protein that works.
Yeah, protein that
Yeah.
works. Is that all proteins that work, or just like a specific protein?
Well, it turns out that the hard part, if you take a bunch of amino acids and string them together randomly, you'll get a flippy-floppy mess that if you put it inside a cell, will get chopped up and recycled. The cell will very quickly recycle that into amino acids. So the hardest part, the first hard part, is to get the sort of sequence that folds into one of those shapes that I showed you, where it actually collapses and becomes a compact, well-formed, stable shape. And then the next hard part would be, what do you put on this shape so that the shape actually does something, right? And so the one that I showed you, beta-lactamase, that chews up the penicillin, it has to have a string. This one has like 200 and, whoops. Where is that? Right here. That's a single protein chain, but it has the remarkable properties of specifying a folded shape within the sequence of amino acids on the chain, and this is the shape that gets specified. And then once you've got that shape, you can't see it here. I'd have to show you lots of pictures. It won't hold on to penicillin like that and break the penicillin unless it's got very special tool-like amino acids at the point where it has to bind that penicillin. So a lot of things have to go right for a protein chain to do chemistry like what this is doing. Did I answer your question? Somewhere in there?
Well, my question was more of like, if you went from like an evolutionary standpoint, like, and if there's like no, if it's anything of a chance, you're not, the goal of like what's happening is not to get that, it's to get a protein that would work. So
Right.
I'm wondering, like, what's the odds of like getting just like a protein that like would actually work?
Right. You have to solve this folding problem. So it's about, so the paper shows it's about 1 in 10 to the 77th power to get doesn't have to be this structure, to get anything that's folded to a structure that can perform an enzymatic function. And then if you look at what life does with enzymes, almost nothing is just one enzyme. It almost always requires suites of enzymes, like 20 of them, to make a vitamin that your body uses would require dozens of enzymes. To make one of the amino acids requires dozens of enzymes working together. So it's much, much harder than just this one problem. Any other questions?
What about the argument?
Remind me of your name.
I'm Josh.
Josh.
Yeah. What about the argument of even if there's just a slight chance, what about the argument of like an infinite time universe? It's like, well, just give it more time. It will eventually happen, like if you're measuring it up to infinity.
Yeah. So, and that's where the term fantastically improbable can be helpful, because scientists don't think that the universe is infinitely old. So if you take current cosmological estimates, and you can argue about whether they're right or not, but the current accepted estimates are 15 billion year old universe, and it's not infinitely massive. So there's a certain number of particles in the universe. If you go through that sort of calculation, you can say there's only so many chances for something to have come together, and once it's far less probable than that number, then you can't get it in this universe. But some could also, it's the Jim Carrey argument, right? Where, was it Dumb and Dumber? Now, what are the odds of a guy like me making it with a girl like you? Say 1 in 100? And she says, more like 1 in a million. He goes, so there is a chance. So you can always say, if it's not zero, and that is an argument that people say, well, it's not zero. The problem is this. If you're trying to put forward a theory and say that it's a scientific theory, then you're having to show that it's actually likely that this happens. It's not a scientific theory once you're saying, well, I acknowledge that it's very unlikely that this would work, but it could have worked. You're no longer doing a scientific theory. Then when you add to it what we talked about yesterday, which is it categorically impossible for a physical process to produce us? And I'll hit the microphone again. If we're not just physical, then the answer is yes. It's categorically impossible for a physical process to produce something that isn't just physical. Now the probability is 0, because it's categorically impossible. Yeah, so those are the ways I would go on that. Great question, Josh, from Arizona. Are you from Arizona? Okay. Was there a hand up back here? No. Isaac. Yes, and people do say that.
Well, I said, to play devil's advocate, one would, like, I know people could argue this, but that would be like, it's more fantastically improbable that there is a God, rather than the fact of, like, a chance chemical reaction that occurred over a span of time.
So a good way Richard Dawkins went this direction in a film that came out in 2008 called Expelled, No Intelligence Allowed. I don't know if anyone's heard of it. But it was Ben Stein versus Richard Dawkins. And Richard Dawkins said, well, I think God's very improbable. And Stein said, how improbable? Because once you start saying probability, now you're talking math. So tell me how you did your math. And so people can say that, but call their bluff and say, oh, show me your calculation. They don't have a calculation. So he realizing that Stein was calling Dawkins' bluff, Dawkins said, I'm not comfortable putting a number on it. I just think it's improbable. And even if someone says that, you can say, okay, so you're saying the probability is less than 0.5, right? I'm not comfortable putting a number on it. If you're saying the probability is less than 0.5, show me your math. They don't have it's pure bluff. So if someone says that, ask for the math. Pure bluff. Good point, though. Any other questions before we do boys' night? Oh, yeah, boys' night. Thank you, all.